Alright, my dear JEE aspirants, this time I'll be taking 2025 JEE main covering both January and April shift of the continuity and differentiability chapter. It's a quite important chapter, you know. Totally, we have 13 questions in this session, okay, of both January and April shift on the topic continuity and differentiability, okay. We'll discuss the questions one by one and also see the number of questions asked from different topics, okay. The weightage, continuity and differentiability covering both January and April shift. Number of questions asked from finding unknowns using the definition of continuity. 3 questions are asked. Continuity and differentiability. Here normally they ask finding points of discontinuity and the points where the function is non-differentiable. Let m be number of points where the function is not continuous and n be number of points where the function is not differentiable. Okay, some complicated function be given to you. That's a usual NTA's favorite question. Many times they ask. Such 4 questions are there. And functional equation. This also has become a very favorite for NTA. Questions asked on finding derivative of a function or sometimes only on functional equation. Okay, they'll ask discontinuity of greatest integer function. Commonly asked question. And miscellaneous, 1 question of mixing type is there. Totally we have 13 questions altogether from continuity and differentiability chapter covering both January shift and April shift. Okay, we'll discuss the questions one by one. Function f of x given is tan of tan x minus sin of sin x divided by tan x minus sin x is continuous at x equal to 0. Want to find f of 0. Question asked on 7th of April, second shift, JEE main 2025. So we need to find the value of f of 0 so that this function becomes continuous. Function becomes continuous means limiting value should be equal to function value, correct? Limit x tends to 0, f of x should be equal to f of 0. For f to be continuous at x equal to 0, for f to be continuous, f to be continuous at x equal to 0. What we have, limiting value should be equal to function value. Limit x tends to 0, f of x is equal to f of 0. I need to find f of 0 here. Limit x tends to 0. Limit x tends to 0. Take the function given there. Function given is tan of tan x minus sin of sin x divided by tan x minus sin x. Tan of tan x minus sin of sin x divided by tan x minus sin x. Is equal to f of 0. What we'll do is I'll write to evaluate this limit. It takes 0 by 0 form. If you apply limit directly, tan 0 0, sin 0 0, denominator 0 minus 0 0, tan 0 0, again tan 0 0, sin 0 0, sin 0 0, 0 minus 0 by 0 minus 0 becomes 0 by 0 form, indeterminate form. Applying L'Hopital's rule is not so easy here, becomes extremely complicated. So I'll be using some techniques of trigonometry and also use series expansion, infinite series expansion, so that I can get the answer easily. Okay. So first of all, what I'll do is I'll use sin x as tan into cos. You know, tan is sin by cos. You know that tan x is sin x by cos x. Tan x is sin x divided by cos x. So what is sin x? Tan x into cos x. Cross multiply. Tan is sin by cos, sin is tan into cos. I'll be using this first. So from this I can write sin x is equal to tan x into cos x. Tan x into cos x. So that I can take tan x common there. Okay. I'll write sin as tan into cos. Here, this part. I'll write sin x as tan x into cos x. Okay. Writing sin as tan into cos. So that tan x is common in the denominator. If tan x is taken common, what remains? 1 minus cos x. Correct? Tan x is taken common. What remains is 1 minus cos x in the denominator. This becomes limit x tends to 0. tan of tan x minus sin of sin x, denominator tan x common, so I'll write 1 minus cos x. We know limit x tends to 0, 1 minus cos x by x square is half. One of the important limits is that standard limit. Limit x tends to 0, 1 minus cos x by x square is half. I'll be using this. 1 minus cos x divided by x square is equal to half. So what we'll do is multiply and divide by x square. Divide by x square, multiply by x square. So that 1 minus cos x by x square is half. Is a limit, standard limit in trigonometry, limit of trigonometry function. So this is half. Okay. So this is going to be equal to half. This part is going to be equal to half. So 1 by 2 becomes 2. This 2 will go up to numerator. So what I'm going to get is limit x tends to 0. 2 will keep outside. Okay. 2 will keep outside. 2 into what is left is limit x tends to 0. Tan of tan x minus sin of sin x. Tan of tan x minus sin of sin x divided by what is left out, tan x into x square, correct? This 1 by 2. 1 minus cos x by x square is half. 1 by half is 2. Tan x by x 1. Again I'll multiply and divide by x. The denominator, I'll write this as tan x. I'll divide by x. And here multiply by x. Already x square is there. X square into x becomes x cube. And no, limit x tends to 0. Tan x by x is 1. So denominator is 1 into x cube, x cube. Now tan of tan x minus sin of sin x by x cube. For tan of tan x, I'll apply series expansion formula. You know, series expansion for tan x and sin x. You must be knowing the series expansion for tan and sin. Tan x is, the series expansion for tan x is x plus x cube divided by 3 plus 2 by 15 x power 5 etc. up to infinity. Sin x is what? Sin x is x minus x cube by 3 factorial, x cube by 3 factorial plus x power 5 divided by 5 factorial etc. up to infinity. So tan x by x is 1. So what is left is equal to f of 0 is there on right hand side, is equal to f of 0, correct? So what is left now? 2 into limit x tends to 0. For tan of tan x, I'm using the series expansion. In place of x we have tan x. Tan x is x plus x cube by 3 plus 2 by 15 x power 5 etc. Tan of tan x will be replace x by tan x and write. That will be what? Tan x plus tan cube x divided by 3 plus other terms not required, okay? Because I need only up till x cube terms or cubic, because denominator is x cube, no? Only till cube is enough, because other terms will become 0. Even though if you write, no use, does not matter. Sin of sin x. Sin x we know series expansion. So sin of sin x, replace x by sin x and write sin x minus sin cube by 3 factorial plus sin power 5 by 5 factorial etc. up to infinity. Only up till power 3 is enough. So what we'll write is sin x minus sin cube x divided by 3 factorial, correct, plus and so on, close the bracket, divided by what we have is x cube. Now tan x minus sin x by x cube we can find out separately, okay? So from this what we get, this is 2 into what we have is limit x tends to 0, tan x minus sin x will put in one bracket, tan x minus sin x divided by x cube, tan x minus sin x divided by x cube, that is one term. Next what we have is here tan cube x by 3, minus of minus becomes plus, tan cube x by 3 plus sin cube x by 3 factorial is 6, correct? So tan cube x divided by 3 minus of minus plus sin cube x divided by 3 factorial is 6 This whole thing is divided by x cube, right? I'm separating the terms. So divide this by x cube. Divided by x cube. Like this it goes on. And whatever terms I didn't write, no, all those terms will become 0. Because power of numerator is big. Sine power 5, tan power 5 I'll get. Tan cube by x cube will be 1 and 1 x square will remain. Tan square remains. Tan, suppose you're writing the terms with tan power 5x. 2 by 15, tan power 5x by x cube. Tan power 5x by x cube means tan cube by x cube into tan square. Tan cube x by x cube is 1. Tan square x will become 0 because limit x tends to 0 is there. So whatever terms I didn't write, everything will become 0. That will be equal to f of 0. Okay. And tan cube x by x cube is 1. Correct. This by this 1. Sin cube x by x cube is 1. So what remains is 1 by 3 plus 1 by 6. 1 by 3 plus 1 by 6 is half. And this is also half. This is also another standard limit we have. Limit x tends to 0, tan x minus sin x by x cube is also half. Because we know a limit of trigonometry function. Sin I told, as I told, sin you can write tan into cos. Correct, I'll show this step here if you want. Limit x tends to 0, tan x minus sin x by x cube. Tan x you keep as it is. Sin x you can write tan into cos. Sin x is tan into cos. Divided by x cube. So we can take tan x common here, correct? So what we'll get is limit x tends to 0. Limit x tends to 0. If you take tan x common, tan x is common. So what remains is 1 minus cos x, correct? Divided by x cube is x into x square. Tan x by x is 1. And 1 minus cos x by x square is half. 1 into half is half. So remember, limit x tends to 0. Tan x minus sin x by x cube is half. That is also very standard. So 2 into, after applying limit, this becomes half. Even this is 1 by 3 plus 1 by 6. That is also half. Rest all other terms are 0. That should be equal to f of 0. Half plus half is 1. 1 into 2 is 2. Therefore, my f of 0 is equal to 2. Over. Answer is 2. Answer is 2. So quite different type of question asked for the first time. The composite function is given. Function of function in limits here. Tan of tan x minus sin of sin x by tan x minus sin x. Here important thing you should know is the series expansion for tan x and sin x. Tan x series expansion is x plus x cube by 3 plus 2 by 15 x power 5 etc. up to infinity. And sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial etc. up to infinity. Alternate plus minus for that. And tan cube x by x cube is 1 as x tends to 0. Sin cube x by x cube also 1 as x tends to 0. All higher powers I didn't write. Sin power 5, tan power 5, all those things I didn't write. Because sin power 5x divided by x cube. Sin power 5 could be written as sin cube into sin square. Sin power 5 by x cube is sin cube into sin square by x cube. Sin cube by x cube is 1. 1 into sin square as x tends to 0. Sin square x becomes 0. All higher terms, no, whichever didn't write, all those terms will become 0. And tan x minus sin x by x cube is half. Limit of this is half shown here. I wrote sin as tan into cos. Sin is tan into cos because tan is sin by cos. Sin is tan into cos. Take tan x common. 1 minus cos x by x cube. And x cube is x into x square. Tan x by x 1. 1 minus cos x by x square is half. 1 into half is half. Correct? Clear. Move on to the next one. Answer is half plus half 1. 1 into 2, 2. F of 0 should be equal to 2. Using series expansion, using also this theorem is used. Limit x tends to 0, 1 minus cos x by x square is half. Okay, I used it here. I multiply and divide by x square here. 1 minus cos x by x square is half. So this 1 by 2 becomes 2. 2 is sent to the numerator. And tan x, no, here you multiply and divide by x. This becomes x cube. Tan x by x is 1. So denominator has become x cube finally. And go on simplify using series expansion and also use limit x tends to 0. Tan x minus sin x by x cube is half. Move on to the next one. Number of points of discontinuity of the function f of x equal to greatest integer value of x square by 2 minus greatest integer value of root x for x belongs to 0 to 4. How much is to find out? Greatest integer function. X belongs to 0 to 4. We know that greatest integer function is discontinuous at every integral points. So that's the main thing. The greatest integer function we can call GIF. Question asked on 7th of April, first shift, JEE in 2025. GIF, greatest integer function is discontinuous at every integral points. You must know this. GIF is greatest integer function is discontinuous at every integral points. is discontinuous at every integral points. So where x square by 2 becomes integer, you must see. Where x square by 2 becomes integer, you must see. And where root x becomes integer, you must see in the interval 0 to 4. X belongs to 0 to 4, x square belongs to 0 to 16, correct? X square by 2 will belong to 0 to 8. And there is a theorem that if a discontinuous function is given, two discontinuous functions are there, discontinuous function minus discontinuous function can become continuous also, correct? So x belongs to 0 to 4. As x belongs to 0 to 4, x square belongs to 0 to 16. This implies x square will belong to the interval 0 to 16. Therefore, x square by 2 will belong to the interval 0 to 8. Correct? 0 to 8. In the interval 0 to 8, where x square by 2 becomes integer, at such point there is a possibility that this function can become discontinuous. Okay? The possibilities I am writing, where this greatest integer value of x square by 2 can become discontinuous. So x square by 2 equal to 0, x square by 2 equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. The possibilities I am writing where x square by 2, greatest integer value of x square by 2 can be discontinuous, taking x square by 2 as integer in the interval 0 to 8. If x square by 2 is 0, x square by 2 is 0, x square is 0, correct? X square values are what? X square values are 0, 2, 4, 6, 8, 10, 12, 14, 16. Taking in the positive values, x equal to how much? 0, root 2. Negative value is not writing because negative value does not lie in the interval 0 to 4, right? Only positive values are writing. Root 4 is 2, root 6, root 8, which is 2 root 2, root 10, root 12, root 14, and root 16 is 4. These are the possibilities where greatest integer value of x square by 2 can be discontinuous. Not sure, because discontinuous minus discontinuous can be continuous. Now go to this. As x belongs to the interval 0 to 4, as x belongs to the interval 0 to 4, where is root x belongs to? Root x will belong to, root 0 is 0, root 4 is 2. So 0 to 2, where root x can be integer. Root x is equal to 0, correct? Root x is equal to 0, root x equal to 1, root x equal to 2. If root x is 0, x is 0, correct? Root x is 1 means x is 1, root x is 2 means x is 4, 0, 1, 4. So these are the possibilities where greatest integer value of root x can be discontinuous, 0, 1, 4. Now see the common points. What are the common points we get here? 0 is a common point here, 4 is a common point, correct? At all other points, leaving 0 and 4, the function is definitely discontinuous. Because here at root 2, this function is discontinuous, correct? And this is continuous at root 2. Because when you put x equal to root 2, root of root 2, it is a non-integral value. For every non-integral value, greatest integer function is discontinuous. For every non-integral value, greatest integer function is continuous. So when you put x equal to root 2 here, greatest integer value of root of root 2. Root of root 2 is a non-integer value, therefore definitely discontinuous. Discontinuous minus continuous is definitely discontinuous. So I can give guarantee that at root 2, 2, root 6, root 8, root 10, root 12, root 14. 1, 2, 3, 4, 5, 6, 7. 7 points. I can give guarantee that the function is going to be discontinuous. Even at x equal to 1, you see, at x equal to 1, this function is discontinuous. What about this function? When you put x equal to 1, 1 squared by 2. 1 squared by 2 is 1 by 2, which is a non-integral value. Non-integral value means this becomes continuous. This is continuous, this is discontinuous. Continuous minus discontinuous is discontinuous. So at x equal to 1 also the function is discontinuous. Now I need to verify the common points only. Because at common points the function, here it is discontinuous minus discontinuous can be continuous. That's the thing. So I need to check at x equal to 0 and x equal to 4 only. At the common points we find out. 0, at 0 we can't find left hand limit. 0 and 4 are the endpoints of the interval. So at 0, 0 is the left end point of the interval. There you need to find right hand limit and function value. 4 is right hand point, correct? It's a right end point of the interval. There you can find out the function value and the left hand limit. So verify the continuity at x equal to 0 and 4 only. Okay. At x equal to 0 what happens? At x equal to 0, we need to find f of 0. F of 0 is how much? 0 square by 2, 0. Integral value of 0, 0. Root 0, 0. Integral value of 0 is 0. So f of 0 is 0 minus 0, 0. At 0 we can't find left hand limit because left hand limit means it goes outside the interval. Left side of 0 means outside the interval. So only to find right hand limit at x equal to 0. Limit x tends to 0 plus we find out. Limit x tends to 0 plus of f of x. 0 plus means what? Slightly greater than 0. Say 0.1 you take. 0.1 square is 0.01. 0.01 by 2 is 0 point something. Integral value of 0 point something is 0. Here root of 0.1 is 0 point something. Integral value of 0 point something is 0. So 0 minus 0 is 0. So function is continuous. Therefore limiting value equal to function value. Limit x tends to 0 plus f of x is equal to f of 0. Limit x tends to 0 f of x equal to f of 0. F is continuous at x equal to 0. F is right continuous at x equal to 0. We can't discuss left hand limit there because it goes outside the interval. At 4 what happens? At x equal to 4 you check. Next at x equal to 4. At x equal to 4. Find out the function value. F of 4. Put x equal to 4. 4 square is 16. 16 by 2 is 8. Integral value of 8 is 8. Correct? Here when you put x equal to 4, root 4 is 2. Integral value of 2 is 2. Correct? When you put x equal to 4, 4 square 16. 16 by 2 is 8. Integral value of 8 is 8. And root 4 is 2. Integral value of 2 is 2. 8 minus 2, 6. Now at x equal to 4, I have to find out the left hand limit. I can't find right hand limit. X tends to 4 minus f of x. 4 minus means what? Slightly less than 4. So 3.9. 3.9 square. 4 square is 16. 3.9 square will be 15 point something. 15 point something divided by 2 7 point something. 7 point something integral value is 7. Correct? Again I repeat if you want. 4 minus means slightly less than 4. 3.9 something. 3.9 something means if you square it becomes 15 point something. 15 point something by 2 is 7 point something. Integral value of 7 point something is 7. 3.9 you took. Root of 3.9 is 1 point something. Integral value of 1 point something is 1. Correct? So I'll get same. I'll get same value. Therefore limit x tends to 4 minus f of x. We can't discuss 4 plus. We can't discuss 4 plus because 4 plus goes more than 4. More than 4 is outside the interval. Similarly here we can't discuss x tends to 0 minus. 0 minus means less than 0. Will go outside the interval. So only 0 plus here. At 0 you should find function value and right hand limit. At 4 you have to find function value and left hand limit. Both are equal here. Correct? Therefore function is continuous at x equal to 4. F is, or I can write conclusion, F is continuous at x equal to 4. So, which are the points of discontinuity for this? Points of discontinuity are 1, 2, 3, 4, 5, 6, 7, 8. 8 points. Correct? Number of points of discontinuity of this function is 8. Which is root 2, 2, root 6, root 8, root 10, root 12, root 14 and 1. Okay? At 0 and 4, at the common points, the function becomes continuous. So, discarded. So 0 and 4, the function becomes continuous. Remaining 8 points. Here I am getting 7 points. Here I am getting 1 point. The function is discontinuous. This type of question also commonly asked. Even in 2024 JEE also 2 such questions are asked similar to this. Move on to the next one. Question number 3. F of x given like this is continuous at x equal to 0. Want to find e power a into b into c equal to how much? Function is continuous means left hand limit equal to right hand limit equal to function value. All the same. X less than 0 is left hand limit. X greater than 0 is right hand limit. X equal to 0 is function value. Left hand limit is what first? Left hand limit. Limit x tends to 0 minus. limit x tends to 0 minus of the function f of x 1 plus ax to the power 1 by x. We know that limit theorem is the limit x tends to 0, 1 plus x to the power 1 by x is e. You must know this. Limit x tends to 0, limit x tends to 0, 1 plus x to the power 1 by x. What is there here? The reciprocal should be present in the power. Then it becomes equal to e. Limit x tends to 0, 1 plus x power 1 by x is e. So 1 plus ax is there, no? Ax, the reciprocal should be present in the power. So 1 by ax should be there in the power. Then it becomes e. What is there here? Reciprocal should be present in the power. Here ax is there, no? Reciprocal of ax is 1 by ax. If it is present, then it becomes e. But reciprocal, what is present in the power is 1 by x, not 1 by ax. It should be 1 by x. If it is like this, limit x tends to 0, limit x tends to 0, 1 plus ax, 1 plus ax to the power 1 by ax, then it becomes equal to e. So what I'll do is, I'll multiply and divide by a in the power. Limit x tends to 0 minus 1 plus ax to the power 1 by ax, correct? I multiply and divide by a in the power. This entire thing to the power a, I'll write. What I did in the power, multiply and divide by a. In the power, I'm multiplying and dividing by a. So 1 plus ax power 1 by x, that becomes e according to this. Whatever present here, reciprocal should be present in the power. Ax reciprocal is 1 by x. So multiply and divide by a in the power. So terms inside the bracket is e. This becomes e power a. That is left hand limit. And the function value at x equal to 0, f of 0 is 1 plus b. F of 0 is 1 plus b. And you can find out the right hand limit. Right hand limit is limit x tends to 0 plus. Limit x tends to 0 plus. X 0 plus means slightly greater than 0. That is x greater than 0. We have this, correct? X plus 4 to the power half, x plus 4 to the power half minus 2 divided by x plus c to the power 1 by 3 minus 2. See, here as x tends to 0, numerator is becoming 0 plus 4 is 4, 4 power half is 2, 2 minus 2 0. Numerator is becoming 0 and denominator also should become 0. Otherwise 0 by non-zero will become 0, which is not so here, 1 plus b, correct? B is not 0 here, I can tell, 1 plus b is not 0 because if 1 plus b is 0, b will be minus 1, correct? That's not possible here. Here for limit, no, for limit to exist finitely and to be non-zero, as x tends to 0, numerator is becoming 0, denominator should become 0. I insist the condition that denominator should become 0, correct? So that takes 0 by 0 form. Otherwise, right hand limit becomes 0. Left hand limit is already e power a, no, exponential function can never become 0. That is also there. See, if x tends to 0, numerator is already becoming 0. If denominator is non-zero, what happens? 0 by non-zero is 0. Right hand limit becomes 0. But left hand limit is e power a. Exponential function can never become 0. Note that e power a is not equal to 0 for all a belongs to R. Note that exponential function e power a is not equal to 0 for all a belongs to R. If right hand limit is 0, then left hand limit should be 0, no, for function to be continuous. If left hand limit is 0, right hand limit is 0, left hand limit is not 0, then the function is not continuous. Left hand limit is not equal to right hand limit means what? Function becomes discontinuous. Not so. It is given to be continuous. Therefore, I insist the condition that denominator should become 0 so that it takes 0 by 0 form. One can apply L'Hopital's rule and get a finite answer. Correct? I'll write the sentence here. As x tends to 0 plus, what happens? Numerator is tending to 0. Numerator is becoming 0, correct? When you put x equal to 0, 0 plus 4 is 4, 4 power half is 2, 2 minus 2, 0. Numerator is becoming 0. Implies denominator should be 0. Denominator should tend to 0. So that it takes 0 by 0 form. On the contrary, if numerator is 0 and denominator is non-zero, 0 by non-zero, 0. That means right hand limit is 0. But left hand limit is already e power a. E power a can't be 0. Right hand limit is 0. Left hand limit is not 0. That means left hand limit is not equal to right hand limit. The function becomes discontinuous. It becomes a contradiction to this. So we insist the condition that denominator is becoming 0. If denominator is 0, I can find the value of c. For denominator, you put x equal to 0 and write. What I am getting? 0 plus c. 0 plus c to the power 1 by 3 minus 2. That should be equal to 0. When you put x equal to 0, denominator should become 0. C power 1 by 3 is equal to 2. C power 1 by 3 is equal to, cubing on both sides, I'll get C is equal to 8. C is equal to 8. Cubing on both sides. 2 cube is 8. C power 1 by 3 cube is C. So C should be equal to 8. For C equal to 8 it becomes 0 by 0 form, we can apply L'Hopital's rule. Therefore, once you got value of C equal to 8, I can use right hand limit now. Therefore, right hand limit I can find out. Right hand limit is equal to, limit x tends to 0 plus, limit x tends to 0 plus, what we have? X plus 4 to the power half minus 2 divided by, C we got 8, so x plus 8 to the power 1 by 3 minus 2 takes 0 by 0 form. Can apply L'Hopital's rule, apply LH rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. What we get? Limit x tends to 0 plus. Derivative of x power n. N into x power n minus 1, right? You can use that. Half into x plus 4 to the power half minus 1. Half minus 1 is minus half. Derivative of 2 is 0. Derivative of x plus 8 power 1 by 3 is 1 by 3 into x plus 8 to the power 1 by 3 minus 1, which is minus 2 by 3. Derivative of 2 is 0. Apply limit. Put x equal to 0. This 3 will go up. Correct? Becomes 3 by 2. 3 goes up. 2 comes down. Put x equal to 0. 0 plus 4 is 4. 4 power minus half. 4 power minus half. Divided by 0 plus 8 is 8. 8 power minus 2 by 3. 8 power minus 2 by 3. You can write this as 3 by 2 into 4 power minus half is 2 square power half. 2 square power minus half. It's 1 by root 4 I can write. Correct? 4 power minus half. 2 square power minus half. So 2 power minus 1, which is 1 by 2. 1 by 2. 8 power minus 2 by 3. 8 is 2 cube. 2 cube power minus 2 by 3. 2 power minus 2, which is 1 by 4. Correct? 1 by 4. So this will become 2 ones are 2 twos are, 2 goes up, we'll get 3. Correct? 2 ones are 2 twos are, this 2 will cancel, becomes 3. Right hand limit is 3. Right hand limit is 3, therefore 1 plus b should be 3. For function to be continuous, f is continuous at x equal to 0. Left hand limit should be equal to, right hand limit should be equal to function value. Already we got the value of c, e power a also I need to find out. Since f is continuous at x equal to 0, since f is continuous at x equal to 0, I can write left hand limit equal to right hand limit equal to function value. Left hand limit is equal to right hand limit is equal to function value. Left hand limit we got e power a. Left hand limit is e power a. Right hand limit we got 3. Correct? And the function value we got 1 plus b. 1 plus b. So e power a should be 3. Correct? E power a is equal to 3. I got the value of e power a. I want to find e power a into b into c. Correct? That's what we need to find out. E power a is 3. B how much? If you equate these two, 3 is equal to 1 plus b. So b is equal to 2 I'll get. Correct? B is equal to 2. And c is already 8. C is already 8. 3 into 2, 6. 6 into 8 is 48. Answer is option A. Question answered on 3rd of April, first shift, JEE Main 2025. A nice question is asked. Correct? Equating these two will get value of B is equal to 2. Value of B is equal to 2. And if you equate these two, will get e power a is equal to 3. E power a is equal to 3. Correct? 3 into 2, 6. 6 into 8 is 48. Move on to the next one. Hope it's clear. Exponential function can't be 0. Already told, for any a belongs to R. So this is not equal to 0. This is already 0, means not possible, correct? Therefore, if numerator is 0, denominator should become 0. Important step. Getting the value of c is important here. Then anything is, yeah, then the remaining steps are easy, correct? Move on to the next one. Question number 4. This is a question based on the functional equation actually, but here nothing to do with the differentiation or continuity. But still I have given the question in this section only. I could have included in functions chapter also this question, but I have included here itself. No need to differentiate or use the concept of continuity here. Function is continuous, satisfying the various conditions. It's a question based on the functional equation here. Okay. So f of 0 is 1, f of 2x minus f of x equal to x. From there I need to find out this g of x, then substitute this summation of g of r square. Given f of 2x minus f of x equal to x. I'll start from given equation. Given f of 2x minus f of x is equal to x. From this equation, what we'll do is I'll replace x by 2. Go on, repeat this process and add all the equations so that I'll get this form. I should get f of x minus f of x by 2 power n, and limit n tends to infinity of that is g of x. So replace x by 2 from this. What we do is replace x by 2. Replace x by 2. What we get? This we get f of 2 into x by 2 becomes x, f of x minus f of x by 2, correct, is equal to x by 2. Wherever there is x, you write x by 2. This is called equation 1. Again repeat, again replace x by 2. Again replace x by 2. What we get? F of x becomes x by 2. F of x by 2 becomes f of x by 2 by 2. F of x by 4 it becomes. Is equal to x by 2 by 2 becomes x by 2 square. Again repeat the process like this. Again replace x by 2. Again replace x by 2. What we get? F of x by 2 by 2 becomes x by 4, or x by 2 square I can write, minus f of x by 2 by 4, x by 8 it becomes, is equal to x by 2 cube it becomes, x by 2 by 2 square, x by 2 cube. Continue this process like this. Continue this process. Again replace x by 2. Go on to this. Even this kind of question is asked earlier in the JEE exam. If you see the PYQs, I think in the year 2021 this type of question was asked. Okay, so go on, continue like this. We go to the last step, that is nth step. Okay, nth step we go. This is first step. Second step, f of x by 2. Third step, f of x by 4. I'll go to n minus 1th step. That is n minus 1th step. Okay, that will be f of x by 2 power n minus 1. Okay, minus f of x by 2 power n. This is n minus 1th step. Is equal to x by 2 power n I'll get. Okay, I have first equation, second equation, third equation. This is my n minus 1th equation. Okay, so I'll get like this. Add all these n minus 1 equations. What happens? See here, f of x by 2 is going to cancel. These two are cancelling. These two are cancelling. Last but one step will be f of x by 2 power n minus 2 minus f of x by 2 power n minus 1. So all those terms will cancel. Adding all these equations, what remains is, see, f of x by 2 is cancelling, f of x by 4 is cancelling, correct? F of x by 4 is cancelling. What remains finally is f of x minus f of x by 2 power n. I'm getting this. Adding all these things, this and this will not cancel. These two are cancelling. These two are cancelling. Next step will be f of x by 8 minus f of x by 16. So f of x by 8 will cancel. Correct? What will not cancel is f of x minus f of x by 2 power n. Adding all these we get f of x minus f of x by 2 power n, correct, is equal to, add the right hand sides, x by 2 plus x by 2 square, x by 2 cube, etc. X by 2 plus x by 2 square plus x by 2 cube, etc. x by 2 power n. Apply limit n tends to infinity on both sides. Okay, and this forms a geometric series. Sum to infinity of geometric series a by 1 minus r. We have a beautiful result. Sum to infinity of a geometric series a by 1 minus r for common ratio to lie between minus 1 and plus 1. Correct? We know this. Beautiful result. So applying limit n tends to infinity on both sides. Limit n tends to infinity of f of x minus f of x by 2 power n. F of x minus f of x by 2 power n is equal to what we have. Limit n tends to infinity of x by 2 plus x by 2 square plus x by 2 cube. Last term is x by 2 power n. This forms sum to infinity of geometric series, which is a by 1 minus r. A is the first term, which is x by 2 divided by 1 minus common ratio how much? X by 2 square by x by 2 is 1 by 2. Here the first term is 1, first term is x by 2, correct? And the common ratio, if you do second term by first term, x will cancel. 1 by 2 square by 1 by 2 is 1 by 2. Common ratio is 1 by 2. Common ratio is 1 by 2. Common ratio is 1 by 2. Correct? 1 minus half is half. X by 2 divided by 1 minus half is half. 2 cancels. I am getting x. Limit n tends to infinity, f of x minus f of x by 2 point is defined to be equal to g of x. So I am getting g of x. This is your g of x. This is your g of x. So g of x is x. I am getting g of x as x. Want to find summation r is equal to 1 to 10 g of r square. Therefore summation r is equal to 1 to 10 g of r square. G of x is x. So g of r square is r square. Summation of r square you need to find. Summation r is equal to 1 to 10 of r square. Put r, summation of n square formula, n into n plus 1, 2n plus 1 by 6. Putting n is equal to 10. 10 into 10 plus 1, 11. 2 into 10 plus 1, 21 divided by 6. N into n plus 1, 2 into n plus 1, 2 into 10 plus 1, 21 by 6. Can cancel with 3 table. 3 2s are, 3 7s are, 2 1s are, 2 5s are. 5 into 11, 55, or 5 into 7, 35. 35 into 11 is 385. 385. Option A is answer. Very nice question. For the second time this type of question is asked. First time is already repeated same kind of question in 2021 JEE main. Okay. Please make a note of this. Quite interesting question. But here we not use the concept of differentiation, only based on the functional equation. Just go and replace x by 2 and it forms infinite geometric series. Sum to infinity of geometric series is given a by 1 minus r, where a is the first term and r is the common ratio which lies between minus 1 plus 1. Simplified, get the answer. Summation formula is also used. Summation of n square formula is also used here. Summation of n square is n into n plus 1, 2n plus 1 divided by 6. All the basics you must know, then only it's possible to solve the problems. Summation of n square. Summation of n is n into n plus 1 by 2. Summation of n cube is n into n plus 1 by 2 the whole square. Okay, this formula is used here. Put n is equal to 10 and write summation of n square formula. Move on to the next one. Question number 5. Function f of x given like this is continuous at x equal to 0. Find k1 square plus k2 square. Question asked on 23rd of January, first step 2025 JEE main. So function is continuous means left hand limit should be equal to right hand limit should be equal to function value. Find out left hand limit first. At x equal to 0, left hand limit is how much? Limit x tends to 0 minus. Limit x tends to 0 minus. 0 minus means x is less than 0. So function given is here. 2 by x into sine of k1 plus 1x plus sine of k2 minus 1x. Correct? Function given like this. 2 by x. I can divide whole thing by x. 2 into what I can write is sine of k1 plus 1 into x plus sine of k2 minus 1 into x. Sine of k2 minus 1 into x. Whole thing is divided by x, right? That can be done, correct? 2 by x means 2 into 1 by x. That means this entire bracket is divided by x. Same as telling multiplying by 1 by x. So now I'm using the result. I'll separate this by this and this by this. And use the limit theorem of trigonometric functions. Limit of trigonometric function. Limit x tends to 0. Sin ax by sin bx is a by b. Using this limit theorem. Limit x tends to 0. All these things are given in my synopsis. Please learn the formulas, okay, from the synopsis video of limits. It's already done. Limit x tends to 0. Sin ax by bx a by b. So sin of k1 plus 1 x by x. Coefficient of x is k1 plus 1. Coefficient of x1. Separate the terms. Divide this by this by this. Then apply this result. So left hand limit becomes, if you want to write one more step, limit x tends to 0 minus, limit x tends to 0 minus 2 into, what I can write, sine of k1 plus 1 into x divided by x plus sine of k2 minus 1, sine of k2 minus 1x divided by x. Coefficient of x here, k1 plus 1. Coefficient of x in the denominator is 1. k1 plus 1 by 1. k1 plus 1. This is equal to 2 into limiting values k1 plus 1. For this limiting values k2 minus 1. k2 minus 1. Minus 1 plus 1 cancels. For this as well as this, I am using this. Just write the coefficient of x a. Coefficient of x b. a by b. Sin ax by bx. As x tends to 0 is a by b. So coefficient of x k1 plus 1. Coefficient of x denominator is 1. k1 plus 1 by 1. k1 plus 1. Here k2 minus 1 by 1. k2 minus 1. Plus 1 minus 1 will cancel. So what remains? Left hand limit is 2 times k1 plus k2. Function value is 4. Right hand limit you find out. X greater than 0. That means x tends to 0 plus right hand limit. For right hand limit I am using this function. Right hand limit. Limit x tends to 0 plus. Limit x tends to 0 plus. For 0 plus means x greater than 0. Use the property of log and write log of a by b. You know property of log. Log of a by b is log a minus log b. Log of a by b is log a minus log b. Correct? Log a minus log b. So this becomes what? 2 by x into using the property I can write this as log of 2 plus k1x 2 plus k1x minus log of 2 plus k2x. Like this I get. Now if you apply limit directly, no, 2 plus 0, k1 into 0, 0, 2 plus 0 is to log 2 minus log of 2 plus 0, log 2 minus log 2, 0, 0 by 0 form it becomes. You can apply L'Hopital's rule, correct? You can divide whole thing by x, 2 by x is there, no, 2 into this entire thing divided by x we can write. So that becomes 0 by 0 form. We can apply L'Hopital's rule, differentiate numerator, denominator separately. This is equal to limit x tends to 0 plus 2 you keep there only. Derivative of log is 1 by x. Derivative of log x is 1 by x. Derivative of log of 2 plus k1x. 1 by 2 plus k1x into derivative of 2 plus k1x, that is k1. Correct? 1 by 2 plus k1 into x. Derivative of 2 plus k1x, that is k1. Minus 1 by 2 plus k2x into derivative of k2x, that is k2. Correct? Derivative of k2x is and denominator derivative of x is 1. Correct? Derivative of x is 1. Differentiate numerator and denominator separately. Now I can apply limit at this stage. If I apply limit x equal to 0, 2 plus k1 into 0, denominator is 2 plus 0, 2 it becomes. Correct? If I apply limit for this, 2 into, what I am getting is k1 by 2 plus 0, k1 into 0, put x equal to 0 here, this part is 0, Here this part is 0. K1 by 2 plus 0, that is K1 by 2. Correct? Minus K2 by 2 plus, this is 0. K2 by 2 plus 0 is K2 by 2. These 2 take common denominator and cancel. What you get is K1 minus K2. K1 minus K2. So right hand limit is K1 minus K2. Left hand limit we got 2 times K1 plus K2. Function is continuous at x equal to 0. So left hand limit should be equal to, right hand limit should be equal to function value. Since f is continuous at x equal to 0, f is continuous at x equal to 0 implies left hand limit equal to right hand limit equal to function value. Left hand limit equal to right hand limit equal to function value. What is the left hand limit we got? 2 times K1 plus K2. 2 times K1 plus K2. Right hand limit we got K1 minus K2. K1 minus K2. Function value is x equal to 0. Function value is 4. Combine the first and last. If we combine the first and last, 2 times K1 plus K2 is 4. So K1 plus K2 is 2. I'll get K1 plus K2 is equal to 2. If we combine the second and this, I'll get K1 minus K2 is equal to 4. Solve the two equations simultaneously. Adding the two equations, K2 cancels. 2K1 is equal to 6. Implies K1 is equal to 3. You put K1 equal to 3 in one of the equations. Put K1 is equal to 3. Put K1 equal to 3. In K1 plus K2 is equal to 2. K1 plus K2 is equal to 2. Which gives K2 is equal to 2 minus K1. So 2 minus 3, which is equal to minus 1. Therefore K1 is 3, K2 is minus 1. Therefore want to find K1 square plus K2 square. Correct? Finally we want to find K1 square plus K2 square. K1 square plus K2 square. K1 is how much? 3. 3 square. K2 is minus 1. Minus 1 square. So what we get is 9 plus 1 is equal to 10. Option D. Very simple question on continuity. Just use left hand limit equal to right hand limit equal to function value. And also use these things, property of log and also limit of trigonometry function. To find left hand limit, I'm using limit of trigonometry function. To find right hand limit, I'm using property of log and applying L'Hopital's rule. Because it takes 0 by 0 form, differentiate the numerator and denominator separately. Denominator is x here. 2 is kept as it is. Denominator is x. Derivative of x1. Derivative of log x is 1 by x. 1 by 2 plus k1x into derivative of terms inside the bracket. Derivative of 2 is 0. Derivative of k1x is k1. Similarly here, derivative of log of 2 plus k2x. 1 by 2 plus k2x. Derivative of 2 plus k2x. Derivative of 2 is 0. 2 is constant. Derivative of k2x is k2. k2 into 1. 0 plus k2 into 1. k2. Then apply limit. K1 by 2 minus K2 by 2, that is multiplied by 2. So 2 cancels. Right hand limit is K1 minus K2. Left hand limit is 2 times K1 plus K2. Use definition of continuity at x equal to 0. Left hand limit should be equal to, right hand limit should be equal to function value. Everything should be equal. Therefore, equating the first and last, second and last, I'm getting two equations. Solve the two equations, I'll get the values of K1, K2. K1 square plus K2 square. 9 plus 1, 10. Option D. Question asked on 23rd of January, first shift, 2025, JEE main. Move on to the next one. Question number 6. A function f of x is given like this. X square minus 1 into mod of x square minus ax plus 2 plus cos of mod x be not differentiable at 2 points at x equal to alpha equal to and x equal to beta. Find the distance of the point alpha comma beta from the line 12x plus 5y plus 10 equal to 0 equal to how much? So, the differentiability on modulus function, this question is based on differentiability of modulus function. Now, mod x is not differentiable at x equal to 0. Important thing here you must know is, actually there is a mistake in the question. Okay, I'll tell you what is a mistake. Question mistake is there. Okay, still I am working out and tell you in the beginning itself there is no option matching here because there is a mistake in the question. A faulty question asked. Bonus has to be given for this. Mod x is not differentiable at x equal to 0. We know that. Mod x is not differentiable at x equal to 0. Mod x is not differentiable at x equal to 0. This is a very familiar concept. But x into mod x is differentiable at x equal to 0. But x into mod x is differentiable at x equal to 0. Mod x is not differentiable, but x into mod x is differentiable at x equal to 0 because x will become 0 at x equal to 0, correct? X equal to 0 when you put x equal to 0 in that. In more generally, I can tell mod x minus 1 is not differentiable at x equal to 1. But x minus 1 into mod x minus 1 is differentiable at x equal to 1 because x minus 1, other factor is becoming 0. Same thing is happening here actually. Okay. And mod of f of x is not differentiable at the points where f of x becomes 0, provided the function is continuous. For a continuous function f of x, for a continuous function f of x, what we have is mod of f of x is not differentiable. Mod of f of x is not differentiable at the points where f of x becomes 0. At the points where f of x becomes 0. Mod of f of x is not differentiable at the points where f of x is equal to 0. Okay. So that is there. So mod of x square minus ax plus 2 is not differentiable at the points where x square minus ax plus 2 becomes 0. And already one point they given, the non-differentiable point is given to be x equal to alpha equal to. At x equal to it's not differentiable. They're given already. So you can put x equal to and find out the value of a first. And one more thing is that cos of mod x is differentiable always. Sin of mod x is not differentiable at x equal to 0. But cos of mod x is differentiable for all x belongs to R. Okay. Another interesting thing is cos of mod x is differentiable for all x belongs to R. Even the question is wrong, I am working on because I'll get the concept. Correct? I'll make it correct, the question at the end. Cos of mod x is differentiable for all x belongs to R. The doubtful point is at x equal to 0. Okay. So mod x, more generally, it can be plus x or minus x. Mod x is x if x is greater than or equal to 0. And mod x is minus x if x less than 0. In both the case, see, cos of mod x, it can be cos x or cos minus x. You know, cos of minus x is same as cos x. Therefore, the function becomes differentiable. Correct? See, cos of mod x, I can split into two cases. Cos of mod x is equal to cos x if x is greater than or equal to 0. And it becomes cos of minus x. This is for x is less than 0. Okay? Mod x is x if x is greater than or equal to 0. For x less than 0, mod x is minus x. But cos of minus x is same as cos x. So left hand derivative and right hand derivative becomes equal at x equal to 0 also. Even though if differentiate, derivative cos x is minus sin x. Minus sin 0, 0. Cos of minus x same as cos x. Derivative cos x minus sin x. Put x equal to 0. Sin 0, 0. Minus sin 0. Same as minus 0, 0. Left hand derivative and right hand derivative both are same at x equal to 0. So cos of mod x is differentiable even at 0. So it's differentiable for all x belongs to R. So this function is differentiable for every real number. Okay. Only this function is not differentiable at 2 points. Okay. X square minus ax plus 2 is not, mod of x square minus ax plus 2 is not differentiable at the points where this function becomes 0. Correct? Now using this, mod of f of x is not differentiable at the points where f of x becomes 0. So mod of x square minus ax plus 2. Mod of x square minus ax plus 2 is not differentiable at the points, where x square minus ax plus 2 equal to 0. At the points where x square minus ax plus 2 becomes equal to 0. Already they told that x equal to alpha equal to 2 is one root where it is not differentiable. Put x equal to 2 here. Put x is equal to 2. What do you get? 2 square 4 minus 2a plus 2 is equal to 0. I'll get 6 minus 2a equal to 0. 6 equal to 2a. That means a is equal to 3 I'm getting. A is equal to 3. Okay. Therefore, the function becomes f of x becomes equal to x square minus 1, that is 1 bracket, and this mod of x square minus a we got 3x plus 2, and that cos of mod x you can keep as it is. Cos of mod x you can keep as it is. This is differentiable for all x belongs to R. And this is differentiable for all x belongs to R because it is a polynomial function of degree 2. This is differentiable. This function is not differentiable at the points where x square minus 3x plus 2 becomes 0. x square minus 3x plus 2 becomes 0. X square minus 3x plus 2 0 means x minus 1 into x minus 2 equal to 0, correct? Not differentiable implies x square minus 3x plus 2 is equal to 0. That means we can factorize this x minus 1 into x minus 2 equal to 0, which gives x equal to 1 and x equal to 2. X equal to 1, x equal to 2. But when you put x equal to 1, this factor is becoming 0, correct? This function mod of x square minus 3x plus 2 is not differentiable at x equal to 1 and x equal to 2. When you put x equal to 1, this is becoming 0, right? 1 square minus 1, 0. 0 into this becomes 0. Therefore, the function becomes differentiable. As I told, mod x is not differentiable at x equal to 0. But x into mod x becomes differentiable at x equal to 0 because this other factor is becoming 0, correct? Even though the function is not differentiable means left hand derivative will not be equal to right hand derivative. Left hand derivative is minus 1. Minus 1 into 0, 0. Right hand derivative is plus 1. Plus 1 into 0, 0. So function becomes differentiable at x equal to 0. More generally, I'll tell you, if mod f of x is not differentiable at some point x equal to a, if g of a is becoming 0, okay, then g of x into mod f of x becomes differentiable at x equal to a. That is one more general theorem I can tell. See, suppose mod f of x is not differentiable at x equal to a. Mod of f of x is not differentiable at x equal to a. Okay, if this thing is happening, mod of f of x is not differentiable at x equal to a, and g of a is equal to 0. G of a is equal to 0. If this thing happens, then I can conclude that f of x into mod of g of x into mod of f of x will be differentiable at x equal to a. Will be differentiable at x equal to a. Will be differentiable at x is equal to a. Okay, important theorem, we can take it like this. Important result. If mod f of x is not differentiable at x equal to a, if g of a is equal to 0, at that point the function g is becoming 0, then the product g of x into mod f of x will be differentiable at x equal to a. Hope you understand. Suppose I get another example. Mod x minus 3 is not differentiable at x equal to 3. What about x square minus 9 into mod x minus 3? It becomes differentiable at x equal to 3. Understood? See, mod x minus 3 is not differentiable at x equal to 3. Mod x minus 3 is not differentiable at x equal to 3. Okay. What about x square minus 9 into mod x minus 3? This function becomes differentiable at x equal to 3 because when you put x equal to 3, the other factor is becoming 0. 3 square 9, 9 minus 9, 0. Correct? Will be differentiable at x equal to 0. Will be differentiable at x equal to 3, and it is differentiable everywhere, and it is differentiable for all x belongs to R. At 3 was a doubtful point, at 3 also it becomes differentiable, and every other real number also is differentiable. Hope you understand this. This is the mistake done in framing the question. They blindly done this. They not taken this into fact, this fact to be considered. This fact is not taken into the consideration. Okay. See, x square mod of x square minus 3x plus 2 is not differentiable at x equal to 1 and 2. But when you put x equal to 1, this factor is becoming 0. 0 into this will become 0. Function becomes differentiable. Correct? Why it is not differentiable? Because left hand derivative and right hand derivative are not equal. See, at x equal to 1, this is not differentiable. You may get left hand derivative, say minus 1. This will become 0. No, when you put x equal to 1, 1 square 1, 1 minus 1, 0. 0 into minus 1, 0. If you do right hand derivative, you might get the answer as plus 1 at x equal to 1. I'm just telling you, not sure. I'm not computed. I'm just giving an example. Suppose you get right hand derivative for this function at x equal to 1 as 1. This is becoming 0, no? 1 square minus 1, 0. 0 into 1, 0. 0 into 1, 0. 0 into minus 1 also 0. So because of this function is becoming 0 at x equal to 1, it becomes differentiable. So the thing is they're done wrong here. X equal to beta, beta will get 1. At 1 the function is differentiable. Not differentiable, they don't know. Not differentiable is wrong. So many facts to be learnt here. Cos of mod x is differentiable for all x belongs to R. But sin of mod x is not differentiable at x equal to 0. I'll be doing the synopsis part of differentiability in depth for JEE, synopsis, complete synopsis with examples. I'll be teaching so much of along with graphs also. And I can draw the graph of this function also. The function is not differentiable at the points where there is a sharp edge. The function has sharp edge, no, the function is not differentiable. If you want to draw the graph of mod of x square minus 3x plus 2, the graph is something like this. Graph will be like this. Mod of x square minus 3x plus 2. 1 is here, 2 is here. The graph comes like this. Mod of, this is a graph of mod of x square minus 3x plus 2. X-axis, y-axis, origin. So there is a sharp point here, correct? You can see the sharp point. Where there is sharp point, the function is not differentiable. Where there is sharp point, here there is a sharp point. Here there is sharp point, correct? Function is not differentiable at 1 and 2. But here, because of this factor, the function becomes differentiable. Suppose I change the question here. Suppose I change the question. Instead of x square minus 1, I make it x square minus 2. X square minus 2 I'll make, okay? In that case, the function becomes not differentiable at 1 and 2. You can make x square minus 3 also. You can change the question. You can change this question to x square minus 3 or x square minus 2. In that case, the question becomes correct. In that case, it becomes correct. I'll change this question to x square minus 3. See, this function is not differentiable at 1 and 2. When you put x equal to 1, 1 square 1, 1 minus 3 minus 2, it is not becoming 0. This part is not becoming 0. So therefore, it is not differentiable. When you put x equal to 2, this is not differentiable. But you put 2, 2 square 4, 4 minus 3 is 1. It's not becoming 0. It is not becoming 0 means it is not differentiable. This overall function is not differentiable. So I can change the question instead of x square minus 1, I can make x square minus 3. Don't make x square minus 4 again. If you make x square minus 4, it becomes differentiable because when you put x equal to, this is not differentiable. If you make x square minus 4, 2 square 4, 4 minus 4 becomes 0. Again it becomes differentiable. Don't make x square minus 1, don't make x square minus 4. Leaving that any other value possible. You can take x square minus 100 also, no problem. Function becomes not differentiable only. So taking like this, my alpha is going to be already given 2. Beta we got 1, this is alpha, alpha is 2, alpha is 2, beta is 1, correct? Alpha was given in the question. Using alpha I got the value of A, value of A I got it as 3, correct? That is not required, correct? Alpha, beta, alpha is 2, beta is 1, correct? Now I have to find the distance of this point to the line. Use the formula mod of ax1 plus by1 plus c by root of a square plus b square. So if you apply that formula, d is equal to mod of a into x1, 12 into 2, 24, plus 5 into 1, 5, plus 10, divided by root of a square plus b square. 12 square is 144 and 5 square is 25. This will be 29 plus 10, 39. Mod of 39 is 30. Root 169 is 13. So we'll get the answer as 3. Option A will get, provided you change the question x square minus 1 to x square minus 3 or x square minus 2 or x square minus 5 like that. Then only function becomes not differentiable. If the outside bracket is x square minus 1, the function becomes differentiable at x equal to 1. If you make x square minus 4, then function becomes differentiable at x equal to 2. So don't make this as x square minus 1. Don't make this as x square minus 4 for the statement to be true. Hope it's clear. So much of explanation are given here about the modulus function, all those things. So the important thing is this. Mod f of x is not differentiable at x equal to a. And if g of a is equal to 0, then the product g of x into mod f of x becomes differentiable at x equal to a. Very clear. So this concept is used. Okay. So much of explanation for cos of mod x, sin of mod x. Many things are there to be learned in this. Okay, in differentiability. I'll be doing the depth of synopsis of this, of continuity and discontinuity of modulus function, greatest modulus function of course continuous everywhere, discontinuity of the greatest integer function, the point to be noted, and finding unknowns using continuity, functional equation, differentiability, left hand derivative, right hand derivative, all those things I'll be discussing in detail. The synopsis part for JEE I'll be doing later. Please make a note of this. Move on to the next one. So answer is 3 if you make the correction, otherwise the question is wrong. Okay. Move on to the next one. Question number 7. F of x given like this. There are 3 cases given here and it involves the greatest integer function. Minimum of is there. So 0 to 2 is given here. There and split. 0 to 1 and 1 to 2. I'll make interval wise. I'll rewrite this function, redefine this function. F of x is equal to, I have to find the points where the function is not continuous and not differentiable. Okay. F of x we can rewrite like this. First case 3x, that we keep as it is. 3x. It is for x less than 0. Second case 0 to 2 is there. Now I split at 1 here because greatest in the function is discontinuous at every integral point. So I split at 1 here. 0 less than or equal to x less than 1 and 1 less than or equal to x less than 2, like this I'll do. And for x greater than 2 it's given as 5. For x greater than 2 the function is constant 5. And what happens in the interval 0 to 1? In the interval 0 to 1, for x between 0 to 1 including 0 excluding 1, first simplify what is greatest integer function. Greatest integer function becomes 0, correct? For x between 0 and 1 including 0 excluding 1, 0 less than or equal to x less than 1, what we have? The greatest integer function which is equal to 0, correct? Greatest integer function becomes 0. 1 plus x plus 0, 1 plus x. Here x plus 2 into 0, correct? So it becomes, this is becoming 0, this is becoming 0, it becomes minimum of 1 plus x plus 0, comma x plus 2 into 0, 2 into 0, 0. So minimum of 1 plus x, comma x it becomes. minimum of it becomes 1 plus x, comma x. Okay, putting greatest in the function equal to 0 for 0 to 1. And what about for 1 to 2? For 1 less than or equal to x less than 1, 1 less than or equal to x less than 2, greatest integer function becomes 1, right? Using definition of greatest integer function. For x between 1 and 2, including 1 excluding 2, greatest integer function becomes 1. So greatest integer function is 1 means this becomes what? 1 plus x plus 1. So 1 plus 1 to 2 plus x. Here x plus 2 into 1. So it becomes, this is becoming 1, 1 plus 1 to x plus 2. This is x plus 2 into 1, x plus 2. Minimum of x plus 2, comma x plus 2 will get. Correct? And you put greatest integer function is 1, becomes 1 plus x plus 1, means x plus 2. Here x plus 2 into 1, x plus 2. Minimum of x plus 2 and x plus 2 is x plus 2 only because they are equal, right? Like this I am getting. X plus 2, comma x plus 2 I am getting. If you want, I can write a little bigger one because it has become so small you can't identify it. First case was 3x, that is for x less than 0, correct? And this becomes minimum of what we get for greatest in function equal to 0, 1 plus x plus 0, 1 plus x, x plus 2 into 0, x, 1 plus x, comma x, 1 plus x, comma x. This is if x between 0 and 1. And third case will be minimum of using this 1 plus x plus 1, 2 plus x, x plus 2 into 1, x plus 2, x plus 2, x plus 2, x plus 2, comma x plus 2. If 1 less than or equal to x less than 2. And for x greater than 2 it is 5. Now in the interval 0 to 1 it takes a half you take, which is minimum 1 plus 0.5 or 0.5. 0.5 is minimum, correct? So minimum of 1 plus x and x is going to be x. So still I can rewrite this. And minimum of x plus 2, comma x plus 2 is x plus 2 only because they are equal, correct? Therefore I can rewrite this function f of x as f of x is equal to 3x for x less than 0 and minimum of 1 plus x and x, smaller of those two, will be x. This is for 0 less than or equal to x less than 1 and minimum of x plus 2 and x plus 2 is x plus 2. This is for 1 less than or equal to x less than 2, correct? Less than 2 and at x equal to also I can find out, no? At x equal to what happens? At x equal to 2, that is not written here, correct? When you put x equal to 2, if x is equal to 2, if x is equal to 2, greatest integer value of x becomes equal to 2, correct? When x equal to also is considered. Minimum of 1 plus x plus 2, that will be 3 plus x. This will be x plus 2 into 2. 2 into 2 becomes 4. X plus 4 and this becomes x plus 3. X plus 3 and x plus 4. The minimum of those two will be x plus 3. Correct? For x equal to also you should consider. For x equal to, when x is equal to, greatest integer value of x is 2. 2 plus 1, 3. Correct? Minimum of, it becomes minimum of, when you put x equal to 2 plus 1, 3. Minimum of x plus 3, comma, when you put x equal to, integral value of 2 is 2. 2 into 2, 4. 4 plus x or x plus 4. Minimum of x plus 3 and x plus 4 will be x plus 3. Correct? For x equal to 2 plus 3, 2 plus 4, which is bigger, which is smaller. X plus 3 is smaller. Correct? X plus 3, which is at x equal to 2. And for x greater than 2, it is defined to be equal to 5. Correct? Like this, the function is given like this. I redefine the function. So the doubtful points are, 0 is a doubtful point, 1 and 2. Correct? At 0, left hand limit is how much? X less than 0. 3 into 0, 0. Right hand limit, 0. Left hand limit equal to right hand limit. The function is continuous at x equal to 0. Even f of 0 is 0. At x equal to 1, what happens? X less than 1, left hand limit is 1. X greater than 1, 1 plus 2, 3. So left hand limit is 1, right hand limit is 3. Function is discontinuous at x equal to 1. Correct? At x equal to 0, if you want to write everything, at x equal to 0, what happens? Left hand limit is how much? 3 into 0, 0. Right hand limit is also 0. Correct? X greater than 0, 0. Function value also 0. Therefore, function is continuous at x equal to 0. Next, you take at x equal to 1. At x equal to 1, left hand limit is how much? X less than 1. X less than 1 is, use this second line. Put x equal to 1. Left hand limit is 1. Right hand limit. Right hand limit is how much? For x greater than 1. X greater than 1. 1 plus 2, 3. Therefore, they are not equal. Function is discontinuous at x equal to 1. And every discontinuous function is non-differentiable function. At x equal to 2 next. X less than 2. Left hand limit is 2 plus 2, 4. Left hand limit is 4. Right hand limit for x greater than 2. X greater than 2 is 5. Correct? The function is discontinuous. X greater than 2 function is 5. And the function value is also 5 at x equal to. Left hand limit is for x less than 2. 2 plus 2, 4. They are not equal. F is discontinuous. Discontinuous at x equal to 1. Discontinuous at x equal to. The function is discontinuous and is not differentiable. Correct? The function is not differentiable at x equal to 1 and x equal to 2. What about at x equal to 0? At x equal to 0, derivative of 3x is 3 and derivative of x is 1. F dash of x we find out. F dash of x. F dash of x is equal to how much? Derivative of 3x is 3 here. For x less than 0. Derivative of x is 1. For 0 less than or equal to x less than 1. Only this much is enough. Rest I am not verifying because here and here the function is discontinuous. If it is discontinuous, it is not differentiable. But here you see f dash of 0 minus. 0 minus means left hand derivative, that is 3. F dash of 0 plus is going to be equal to 1. Correct? F is not differentiable at x equal to 0. F is continuous at x equal to 0 but not differentiable at x equal to 0. So alpha and beta, the number of points where function is not continuous and not differentiable. Find alpha plus beta. So points of discontinuity are 1, 2. Correct? And points of non-differentiability are 1, 2 and 0. Is that clear? Please make a note of this. Function is discontinuous at x equal to 1 and 2. I'll write the sentence here. F is discontinuous at x equal to 1 and 2. correct? Left hand limit is not equal to right hand limit. But function is continuous at x equal to 0, but not differentiable at x equal to 0 because left hand derivative and right hand derivative are not equal. F is not differentiable at x equal to 0, 1 and 2. 3 points. The function is continuous means it might be differentiable or need not be differentiable. That is what happening. At 0 the function is continuous but it is not differentiable at x equal to 0. You can draw the graph also. Graphical method also you can try. Okay. By drawing the graph of for x less than 0 it is 3x. Between 0 and 1 x. Like that you can draw the graph and check whether it is continuous or not, differentiable or not. In graphical method also you can try. All those things I'll be teaching in the synopsis part of this. Okay. So alpha is how much? The points of discontinuity. So alpha is 2. They asked to find alpha plus beta. No. Alpha is 2 points of discontinuity and non-differentiability at x equal to 3 points 0, 1, 2. So alpha plus beta equals to 5. Points of discontinuities 1 and 2. So 2 points of discontinuity and 3 points of non-differentiability. And here I am not checking differentiability because every discontinuous function is non-differentiable function. If a function is not continuous, it is not differentiable. 100% guarantee that it is not differentiable. But if the function is continuous, at 0 it is continuous, I can't give guarantee about the differentiability. If the function is discontinuous, 100% guarantee that the function is not differentiable. Every differentiable function is continuous. Every continuous function need not be differentiable. And every discontinuous function is non-differentiable function. Okay, these 3 things you must know. Every discontinuous function is non-differentiable function. At 1 and 2 function is discontinuous, hence it is not differentiable. No need to check the left hand derivative, right hand derivative. Okay, you'll get wrong answer also if you try to do sometimes. I'm telling you, be careful. This method is applicable of finding derivative only if the function is continuous. Every differentiable function is always continuous. Every discontinuous function is always non-differentiable. And every continuous function need not be differentiable. Differentiability implies continuity. Discontinuity implies non-differentiability. And continuity need not imply differentiability. At 0, the function is continuous, but it is not differentiable. Is that clear? Move on to the next one. Question number 8. Here also we have finding the points of discontinuity, not continuous and not differentiable. Question asked on 24th of January, second shift, JEE Main 2025. So we need to redefine this function. There is greatest integer function and also there is modulus function in the interval minus 2 to 3. Okay. So in the interval minus 2 to 3, split this. Minus 2 to minus 1, minus 1 to 0, 0 to 1, 1 to 2, 2 to 3. At all those points I need to split. F of x. F of x is equal to, split this, various cases. Minus 2 to minus 1, first case. X between minus 2 to minus 1. Minus 2 less than x less than minus 1. Minus 1 you can include here. Minus 1 to 0. 0 to 1, next case. Next case is 1 to 2. 1 less than or equal to x less than 2. Then 2 less than or equal to x less than 3. So many cases are there. Minus 2 to minus 1. Say you take any value between minus 2 and minus 1. Greatest in this function becomes minus 2. And you take minus 1.5. Minus 1.5 minus 2 is minus 3.5, negative. In this interval, x minus 2 is negative. So mod of x minus 2 becomes minus of x minus 2. In the interval minus 2 to minus 1, any value you take, greatest integer function becomes minus 2. And mod x minus 2 becomes minus of x minus 2. Okay? Because in the interval minus 2 to minus 1, if you take any value, say minus 1.5, minus 1.5 minus 2 is minus 3.5, negative. Mod of x minus 2 is minus x minus 2. Minus 1 to 0, greatest integer function becomes minus 1. And you take say minus 0.5, minus 0.5 minus 2, minus 2.5, negative. X minus 2 is negative in this interval. So mod x minus 2 is minus of x minus 2. Applying definition of modulus function and writing. 0 to 1. Greatest integer value becomes 0. And you take any value between 0 and 1, say 0.5. 0.5 minus 2, negative. So mod x minus 2 is again minus of x minus 2. 1 to 2, greatest integer function becomes 1, including 1, excluding 2. If you take say 1.5 here, 1.5 minus 2 is negative. So x minus 2 is negative. Mod x minus 2 becomes minus of x minus 2. Minus of x minus 2. 2 to 3, greatest integer function becomes 2. And if you take 2.5, 2.5 minus 2 is 0.5 positive. So mod of x minus 2 is x minus 2. For greater than or equal to 2 means x minus 2 is positive. 2 to 3, x minus 2 is positive. Mod of x minus 2 is x minus 2. Simplify all these things and check the continuity and differentiability, the doubtful points. Doubtful points are minus 1, 0, 1 and 2. At those points you check the continuity first. If it is discontinuous, you can give guarantee that the function is not differentiable. Every discontinuous function is non-differentiable function. And every differentiable function is continuous. Every continuous function need not be differentiable. All those things are there. Okay. So this is equal to f of x simplifies to what? Therefore, my f of x is going to simplify to this. Minus 2 minus x plus 2. Minus 2 plus 2 will cancel. Minus 2 will get. Minus x will get. Minus 2 plus 2 will cancel. Will get minus x. This is minus 2 less than x less than minus 1. Here minus of minus 2 becomes plus 2. Minus of minus 2 becomes plus 2. 2 minus 1 is 1. 1 minus x. We'll get 1 minus x. This is for minus 1 less than or equal to x less than 0. Here 0 minus of x minus 2. That is minus x plus 2. 2 minus x it becomes. For 0 less than or equal to x less than 1. And 1 minus x minus 2. Minus of minus 2 plus 2. 2 plus 1 becomes 3. 3 minus x it becomes. 3 minus x. This is for 1 less than or equal to x less than 2. Here 2 plus minus will cancel. What we get is x. 2 less than or equal to x less than 3. Correct? Like this again. Plus 2 minus will cancel. F of x like this. F of x. Need to check the continuity of the doubtful points. At minus 1 you check. At x equal to minus 1 what happens? At x equal to minus 1. Find out the left hand limit. X less than minus 1. Left hand limit. Minus of minus 1 plus 1. Right hand limit. Right hand limit. For x greater than minus 1. Correct? That is right hand limit. 1 minus minus 1. 2. Left hand limit is not equal to right hand limit. The function is discontinuous at x equal to minus 1. Next to check at x equal to 0. At x equal to 0. What is left hand limit and right hand limit? Left hand limit at x equal to 0. X less than 0. I have to use this. 1 minus 0. 1. Right hand limit. Right hand limit is how much? For x greater than 0. X greater than 0. This part. 2 minus 0. 2. Again, left hand limit is not equal to right hand limit. The function is discontinuous. Go for x equal to 1. At x equal to 1. What happens? Left hand limit and right hand limit. At x equal to 1. X less than 1. 2 minus x. 2 minus 1. 1. Right hand limit. Right hand limit. For x greater than 1. For x greater than 1. 3 minus 1. 2. Correct? So again they are not equal. Function is discontinuous at x equal to 1. And lastly we have the discontinuity possibility at x equal to x less than 2. 3 minus 2. 1. Left hand limit is how much? Left hand limit. X less than 2. 3 minus 2. 1. Right hand limit. For x greater than 2. That is 2. Everywhere I am getting left hand limit is not equal to right hand limit. Correct? F is discontinuous at minus 1, 0, 1 and 2. Because the function is discontinuous at these 4 points, the function is not differentiable at these 4 points. Because every discontinuous function is non-differentiable function. Correct? So F is discontinuous at for x belonging to the set, which set minus 1, 0, 1 and 2, implies f is not differentiable at these points. F is not differentiable for x belonging to the same set minus 1, 0, 1 and 2. Note that every discontinuous function is non-differentiable function. Every discontinuous function is non-differentiable function. Every discontinuous function is non-differentiable function. So because the function is discontinuous at those 4 points, function is not differentiable for those 4 points. So number of points when the function is not continuous is 4. M is 4. Not differentiable also 4. So M plus N is how much? 8. Option C implies M plus N. 4 plus 4 is equal to 8. Option C is the answer. Move on to the next one. Question number 9. F of x be a real differentiable function such that f of 0 is 1. It's a question based on the functional equation. Very nice question asked. This type of question is commonly found in JEE means nowadays. Previously they were asking in JEE advanced also. If you study the PYQs of JEE advanced also, well and good. You'll get enough good practice from 2015 to 2025. Study all the JEE advanced questions also. Okay, I'll be doing JEE advanced PYQs also later after finishing JEE means. Okay, function is a real differentiable function. F of 0 is 1. And the given the functional equation is f of x plus y equal to f of x into f dash of y plus f dash of x into f of y for all x comma belongs to R. For all x comma y belongs to R. Want to find summation n equal to 1 to 100 log of f of n equal to how much? So f of 0 is 1. From the given equation, I'll put x equal to 0 and y equal to 0. Given f of x plus y is equal to f of x into f dash of y plus f dash of x into f of y, given like this. Now put x equal to 0, y equal to 0. Put x equal to 0, y equal to 0. Put x equal to 0, y equal to 0. What do you get? F of 0 plus 0. Correct? F of 0 plus 0 is equal to f of 0 into f dash of 0 plus f dash of 0 into f of 0. 0 plus 0 is 0. F of 0 is how much? F of 0 is given to be equal to 1. I'm using this. F of 0 is 1. F of 0 is 1. 1 into f dash of 0. F dash of 0. Plus f dash of 0. F of 0 is 1. 1 into f dash of 0. F dash of 0. So f dash of 0 plus f dash of 0. 2 f dash of 0. Correct? So 1 is equal to 2 times f dash of 0. That means how much? F dash of 0 is equal to 1 by 2. F dash of 0 is 1 by 2 I got. Now what I'll do is I'll put only y equal to 0. Because my aim is to find f of x. These kind of questions normally we do like this only. Put x equal to 0, y equal to 0. Put y equal to 0 only. Sometimes you put y equal to minus x. That is the way of doing this problem. Okay. That is the thing we should find. That is how we find the f of x. Our main aim is to find f of x using given condition. Only given condition is f of 0 equal to 1 and the given the functional equation is somehow we should get f of x. That's our aim. Okay, so that is how we do. Put x equal to 0, y equal to 0 and use the given condition. Now you put y equal to 0 only in terms of f of x will get. Correct? So that's the way of doing the problem. That's the way of determining the function f of x. So some skills are used here. Okay, so by working out many problems you get used to it. One problem is not enough. 2 or 3 problems of the same category if you take, then it becomes easy for you to understand. I'll be working out many questions. Okay, please subscribe to my channel and forward to your friends. Maximum number of questions will be done. Not only just PYQs, even other questions, non-PYQs also I'll be doing. Even the synopsis also will be done in detail. Okay, so now I'll put x equal to y equal to 0 in star. Call this as star. Now put y equal to 0. Put y equal to 0 in star. Put y equal to 0 in equation star. What do you get? F of x plus y is 0. Only you put y equal to 0. F of x into f dash of 0. Putting y equal to 0. Plus f dash of x into f of y is 0. Already we know f of 0 is 1 and f dash of 0 we got half just now. I'll be using this also. By putting x equal to 0, y equal to 0, we got f dash of 0 equal to half using f of 0 equal to 1. Now, I'm getting f of x is equal to f of x into f dash of 0 which is 1 by 2 plus f dash of x into what is f of 0 which is 1. f of x minus half f of x is half f of x, correct? Half f of x is equal to f dash of x into 1 is f dash of x. From this we can write it as half is equal to f dash of x by f of x. Now we can integrate, okay, on both sides. Integrate this. Integral of half with respect to x is equal to integral of f dash of x divided by f of x. Integrating with respect to x on both sides. Integral of half is half into x. Integral of constant is constant into x. Integral of f dash by f is log f of x. Log of mod f of x actually. Log of mod f of x plus the constant c. We can find the constant c by putting x equal to 0. Okay. Put x equal to 0 in this equation 1. Put x equal to 0. Put x equal to 0 in equation 1. What do you get? Half into 0 is 0. I'll get equation 1 implies left hand side is 0. Half into 0 is 0. 0 is equal to log of mod f of 0 plus a constant c. Correct? 0 is equal to f of 0 is how much? F of 0 is given to be equal to 1. So this becomes 1. And log 1 is 0. So 0 equal to 0 plus c. That gives c is equal to 0. Therefore, equation 1 becomes half x equal to log of mod f of x. Equation 1 becomes log of mod f of x, or simply log f of x. Assume that f of x is positive. Okay, will be equal to half x, because constant term is 0. Constant c we got 0 because using this condition f of 0 is 1. Using f of 0 equal to 1, f of 0 is 1 and log 1 is 0. 0 equal to 0 plus c is 0. Substitute here. Half x equal log of mod f of x, or log f of x is x by 2. So need to find summation n equal to 1 to 100 log f of n. So log f of x by 2, log f of n will be n by 2. Correct? From this we can write log f of n. Log of f of n will be equal to n by 2. Now we can apply summation for this. Want to find summation n is equal to 1 to 100, correct? Log f of n, we got n by 2 from here. Log f of n is n by 2. Substitute here. Log f of n is n by 2. N by 2 means half you keep outside. Half into summation of n is equal to 1 to 100 of n. Summation of n formula. N into n plus 1 by 2. Correct? 100 into 101 divided by 2. Correct? 2 into 2 is 4. 4 ones are 425. So this becomes 25 into 101. 25 into 101 is 2525. 2525. 25 into 100 is 2500 plus 25. 2525 is the answer. Option B. A very nice question asked on functional equation. Similar type of questions you can see in JEE advanced paper also. Okay. Even JEE mains also many times questions are asked based on this. In 2021, 2023 might be, there are questions based on this. Okay. So quite a good question is asked. And also we use integration here. Okay. Just separating the terms and integrating on both sides. Kind of differential equation I can tell, but still I've included in this chapter only, continuity and differentiability itself. It's a very standard question. Okay. Even similar type of question you can find in JEE advanced, I'm sure they have asked this kind of question. Summation of n formula is used here. Okay. Remaining last part is written here. Summation of n is n into n plus 1 by 2 using the formula. Summation of n by half into n by 2 is half into n, half you keep outside. Summation of n is n into n plus 1. Summation of n is n into n plus 1 by 2. That formula is used to get the answer. Move on to the next one. Question number 10. Let a real valued continuous function defined on the positive real axis such that g of x given. Here also integration sign is there. A kind of functional equation, not exactly, but still I have included in this chapter only. Okay, g of x given. I'll be using the Leibniz rule also here. Given g of x is equal to what? Integral from 0 to x t into f of t. 0 to x t into f of t dt. What it is? Apply d by dx of g of x. Differentiate on both sides. I'll be using Newton-Leibniz formula here. Newton-Leibniz formula will be used here. Okay. Differentiating with respect to x on both sides. d by dx of g of x will be g dash of x. G dash of x. Here integration and d by dx are going to cancel out. I am using Newton-Leibniz formula. Substitute the upper limit, differentiate the upper limit. What is upper limit? X. Integration and d by dx are going to cancel out. Substitute the upper limit. Upper limit is x. In place of t, for integration the variable is t. For integration variable is t. Upper limit is function of x. So I am differentiating with respect to x. Lower limit is 0. It's a constant. So substitute the upper limit. In place of t, put the upper limit. Upper limit is x. Wherever there is t, you put x, upper limit. X into f of x into derivative of x, upper limit is 1. Minus, put the lower limit. For t, for integral variable is t, no? Wherever there is t, you put the lower limit. Lower limit is 0. 0 into f of 0 into derivative of 0, 0. This part is gone, 0. So what remains is g dash of x is equal to x into f of x. G dash of x, I am getting x into f of x. This part is 0. Using Newton-Leibniz formula. Okay. By using Newton-Leibniz formula, I got g dash of x. Now f of x is what? I want to find f of r cube. So f of x will be g dash of x by x. What is from g of x cube? We find g of x. Also, what is given here is g of x cube. G of x cube is equal to x power 6 plus x power 7. What you do is replace x cube by x, or you put x cube as t. In other words, put x cube as t, so that x will be equal to t power 1 by 3. Okay, this becomes what? G of x cube is t. What is x? T power 1 by 3. T power 1 by 3 to the power 6. X is t power 1 by 3 to the power 7. This will be how much? T power 1 by 3 into 6 is 2. This will be t power 7 by 3. Now I will put a new variable. Instead of t, put new variable x, not this x, new x. So g of x will be x square plus x power 7 by 3. I want to find summation of f of r cube. So find what is f of x from this. F of x will be g dash of x by x. My aim is to find f of x. So f of x is g dash of x by x. Correct? F of x will be g dash of x divided by x. So find g dash of x from this. G dash of x will be what? Derivative of x square 2x. Derivative of x power 7 by 3 is 7 by 3 into x power 7 by 3 minus 1, 4 by 3. G dash of x. Now g dash of x divided by x, you find out. G dash of x divided by x is equal to how much? Divide by x and write, because I want to find f of x. Divide by x. This becomes 2 plus 7 by 3 into x power 4 by 3 by x will be x power 1 by 3. So g dash of x by x is f of x. This is your f of x using this equation. G dash of x divided by x is f of x. G dash of x divided by x is f of x. So f of x I got. F of r cube is how much? So for f of x I got f of x is equal to 2 plus 7 by 3 into x power 1 by 3. Correct? Now f of r cube is how much? F of r cube is equal to 2 plus 7 by 3 into r cube power 1 by 3. Put x as r cube power 1 by 3. So what will get 2 plus 7 by 3 into r cube power 1 by 3 is r. So f of r cube I got. Now take summation of this. Summation r is equal to 1 to 15 of this. F of r cube is 2 plus 7 by 3. Summation of r is equal to 1 to 15 f of r cube. That means you are taking sum of the terms 2 15 times. R equal to 1 to 15 is there are 15 terms. 2 is summed up. How many times? 15 times. 15 times you are summing up. 2 plus 2 plus 2 plus how many times? 15 times. That means 2 into 15 becomes 30. Plus 7 by 3 into summation of r, where r is 1 to 15. Summation of n formula, n into n plus 1 by 2 there. 7 by 3 into summation of n formula, n into n plus 1 divided by 2. That will be equal to how much? 30 plus, you can cancel 2 ones are 2 8s are, 3 ones are 3 5s are. Correct? 2 ones are 2 eights are, 3 ones are 3 fives are, 5 into 8 is 40, 40 into 7 is 280. 280 plus 30 becomes 310 is the answer, correct? Otherwise 15 into 16 is 240, 240 by 2 is 120, 120, 3 ones are 3, 40s are 40 into 7, 280, 280 plus 30, answer is 310. Option D is the answer. Question asked on 28th of January, second shift, 2025. Please make a note of this. So use Newton-Leibniz formula to get the answer. Please make a note of this. Using Newton-Leibniz formula we got g dash of x equal to x into f of x. My aim is to find f of x. So f of x is g dash by x. Then give a replacement here from g of x cube, find g of x. Then differentiate g dash of x. G dash of x by x is f of x. Then f of r cube. Then take the summation to get the answer. Answer is 310. Option D. What the next one? M and n be the number of points at which the function f of x is given as maximum of x comma x cube, x power 5, etc. x power 21, x belongs to R, is not differentiable and not continuous respectively. Find m plus n. So here the odd powers of x are given. Important point to be noted is only the odd powers of x are given here. X, x cube, x power 5, etc. So when suppose you take x and x cube, where they become equal, x and x cube, any two odd powers of x will become equal at 0, 1 and minus 1, correct? You take any two odd powers of x, say x cube equal to x. If we solve this equation, x cube equal to x means I can write this as x cube minus x equal to 0. You can take x common, so x square minus 1 equal to 0, correct? Which is x into x minus 1 into x plus 1 equal to 0, factorizing it. So I'll split at 3 points. Any two odd powers of x will become 0 at 0, 1 and minus 1, correct? Any two odd powers of x, x power 5 equal to x power 7 will become equal, correct? X power 5 equal to x power 7 satisfies for 0, satisfies for 1, even for minus 1. You can verify. Any two odd powers of x, here only odd powers of x are given. They will become equal only at 3 points, 0, 1 and minus 1. That is sure. Okay, so I'll split at those 3 points, minus 1, 0, 1. So I'll consider different cases and find which is maximum. See, for x greater than 1, which is bigger, say take x equal to 2, the highest number will be x power 21, right? For x is greater than 1, maximum is bigger of the number, which is bigger among all these things. X power 21 is bigger, correct? So for x greater than 1, x power 21 is maximum among all these things. If you take a number between 0 and 1, say half. Half is bigger or half cube is big? Half is big, correct? Half cube becomes small, half power 5 becomes still small. The powers, as you increase the powers, the number becomes less and less. So half to the power 21 still closer to 0, becomes very less. So there are cases now. For x less than minus 1, x between minus 1 and 0, 0 to 1 and greater than 1. Different cases I'll consider. Note that for x greater than 1, the function like this, x power 21 will be greater than, x power 19 is greater than, x power 17 is greater, like this it goes on. And the least one is going to be x, for x greater than 1. If you take numbers between 0 and 1, for numbers between 0 and 1, for x between 0 and 1, it will be the other way. X power 21 is going to be the least, x power 21, x power 19, like this it goes on, x power 17, like this. X will be the greatest for between 0 and 1. Likewise, I can consider between minus 1 to 0 and less than minus 1. If you take for x between minus 1 to 0, say you take minus half. Minus half is big or minus half cube is big? Minus half and minus half cube. Minus half cube is minus 1 by 8. Minus 1 by 8 is closer to 0. When the number is negative, if it is closer to 0 means it becomes bigger. Minus 1 by 8 is big. And if you take minus half to the power 21, it is become still closer to 0. Correct? So in the interval minus 1 to 0, which will be biggest is x power 21. X power 21 will be the biggest. Again it becomes like this. X power 21 is greater than x power 90, x power 17, like this it goes on. And x will be the least. If you take x less than minus 1, if you take x less than minus 1, what happens? For x less than minus 1, say minus 2. Minus 2 is bigger, or minus 2 cube is bigger. Minus 2 is bigger, because when the number is negative, number closer to 0 is bigger. Minus 2 is bigger, correct? Minus 2 and minus 2 cube. So x is bigger, correct? X is going to be the bigger. So like this it becomes. X power 21 is going to be the least. X power 21, x power 19, x power 17, like this it goes on. X will be the highest number in that case for numbers less than minus 1. So we can divide this function f of x, that is function f of x becomes maximum of this for x less than minus 1, right? First for x less than minus 1, which is going to be maximum is x, correct? For x less than minus 1, minus 2 and minus 2 cube. Minus 2 cube is minus 8, still less. Minus 2 is bigger, so x is bigger. And for x between minus 1 and 0, minus 1 to 0, which is bigger, minus 1 to 0, x power 21 is bigger, correct? X power 21 is bigger. I'll include minus 1 here, because if you include minus 1, anyway, it's minus 1 only. And between 0 and 1, 0 less than or equal to x less than 1. 0 to 1, which is bigger, x is bigger, correct? X is bigger. And for x greater than or equal to 1, x power 21 is bigger. Like this I'm getting. You can check the continuity of the function at doubtful points. Which are doubtful points? Minus 1, 0 and 1. At minus 1 you find out left hand limit, minus 1. Right hand limit, minus 1 power 21, minus 1. At minus 1 it is continuous. Even at 0 it is continuous. Left hand limit 0 power 21, 0. 0 equal, correct? At 0 it is continuous. Even left hand limit equal to right hand limit equal to function value. At 1 also, less than 1, 1. Greater than 1, 1 power 21, 1. Even function value is 1 power 21, 1. Function is continuous at even the doubtful points, minus 1, 0, 1. Function is continuous. Function is continuous everywhere. What about the differentiability? F dash of x. F is continuous for all x belongs to R. You can write the conclusion that F is continuous for all x belongs to R. Even at the doubtful points, the function is continuous. But f dash of x, you find out. F dash of x. Derivative of x is 1. This is for x less than minus 1. And derivative of x power 21 is 20 into x power, 21 into x power 20. 21 into x power 20. 21 into x power 20. This is for x between minus 1 and 0. And derivative of x is 1. This is for 0 less than or equal to x less than 1. And derivative of x power 21 is again 21 into x power 20. This is for x greater than or equal to 1. If you find out the left hand derivative at minus 1, no? F dash of minus 1 minus means left hand derivative at minus 1 is 1. What about right hand derivative at minus 1? Right hand derivative, that is x greater than minus 1. Put x equal to minus 1. Minus 1 power 20 is 1. 1 into 21 is 21. Function is not differentiable at minus 1. At 0 is c. F dash of 0 minus. 0 minus means x less than 0. What is the derivative? 21 into x power 20. Put x equal to 0. 21 into 0. 0. What is f dash of 0 plus? 0 plus means what? X greater than 0. Derivative is 1. Again, not differentiable. And go for finally f dash of 1 minus and f dash of 1 plus. 1 minus means what? X less than 1. Derivative is 1. F dash of 1 plus. 1 plus means what? X is greater than 1. 21 into 1 power 20. 1 power 20 is 1. 1 into 21 is 21. Function is not differentiable. LHD is not equal to RHD. Left hand derivative is not equal to right hand derivative at 1. Even at 0 they are not equal. Even at minus 1 function is not differentiable. Function is not differentiable at minus 1, 0 and 1. But it is continuous everywhere. F is not differentiable at not differentiable for x belonging to the set minus 1, 0 and 1. 3 points. So not differentiable is m, correct? Is not differentiable and not continuous. M is number of points where the function is not differentiable. So m is equal to 3. And n is number of points where the function is not continuous, that is 0. Everywhere it is continuous. Therefore m plus n is equal to 3. M plus n equal to 3. Numerical type question asked. Okay, very nice question, beautiful question. This is on powers, odd powers of x. It is split at minus 1, 0 and 1, less than minus 1, between minus 1 and 0, between 0 and 1, and for x greater than or equal to 1. So various cases are shown. Function is continuous everywhere. Even at the doubtful points, the function is continuous. But it is not differentiable at minus 1, 0, 1. Shown here. Left hand derivative is not equal to right hand derivative. 3 cases shown here clearly. Okay. So very nice questions are asked in the 2025 JEE main of this chapter. Continuity and differentiability. Also you can go by graphical method. I can show the graph of this function. For x less than minus 1. Just a graph like this. X axis. Y-axis, we will draw the graph. For x less than minus 1, the function is minus 1. So x less than minus 1 is here, 0 is here, 1 is here. Less than minus 1, the function is y is equal to x. For less than minus 1, the function is y equal to x. Y equal to x is straight line like this. At minus 1, it is going to be equal to minus 1, right? When you put x less than minus 1, x less than minus 1, it is going to be minus 1, negative value. So function like this. Y is equal to x is a straight line passing through the origin, bisects the first and third chord. So x equal to minus 1 like this it comes. And x power 21 is something like this. X power 21 maybe like this. X power 21 graph. It goes up like this. X power 21 graph. Again y is equal to x, no? Y is equal to x like this. Straight line. Straight line. Then again it goes up like this. So function is continuous, but it is not differentiable at these points. Here it is not differentiable. At these 3 points, the function is not differentiable. Graph is something like this. Straight line, curve, straight line, again curve, like this. X power 21 is curve. Y equal to x is straight line. A rough sketch of the graph is shown here. And it is not differentiable at these points. Minus 1, 0 and 1. Here it is not differentiable. Here it is not differentiable. Here it is not differentiable. Where I put white spots, there the function is not differentiable. Okay. Move on to the next one. Question number 12. Functional equation is given again here. Want to find the second derivative at 5 pi by 3. What we'll do is simplify this first. Sin x into cos y z. You multiply this. Open the bracket. Sin x into cos y. F of x plus f of 2x plus 2y. You see f of 2x plus 2y is found common here. Even here f of 2x minus 2y is common. First we multiply this, open the bracket. What we get is sin x into cos y into f of 2x plus 2y. Okay, multiply this minus sin x into cos y into f of 2x minus 2y is equal to, multiply this, cos x into sin y, f of 2x plus 2y. Multiply inside, cos x into sin y, f of 2x minus 2y. So from this, take common terms. F of 2x plus 2y is found common between this and this. These two, you put in one bracket so that I can take f of 2x plus 2y common. So what I get? F of 2x plus 2y common. What remains is sin x into cos y minus cos x into sin y. Correct? Sin x into cos y minus cos x into sin y. And between these two terms, you take f of 2x minus 2y common. If you take f of 2x minus 2y common, what remains is cos x into sin y plus sin x into cos y, which is sin x cos y plus cos x sin y. Sin x into cos y plus cos x into sin y, which is the compound angle formula, sine of x plus y. This is sine of x minus y, compound angle formula in trigonometry we have. Therefore, what I get is f of 2x plus 2y into, this is sine of x minus y is equal to f of 2x minus 2y, terms inside this bracket is sine of x plus y. From this, we can rewrite this as f of 2x plus f of 2y, f of 2x plus 2y divided by sine of x plus y, correct, is equal to f of 2x minus 2y divided by sine of x minus y. Let this be equal to k. Both of them are equal. Let it be equal to some number k. So I can tell from this f of 2x plus 2y is equal to k into sine of x plus y, correct? So I can write this as f of 2x plus 2y, f of 2x plus 2y equating the first to last is equal to k into sine of x plus y. I need to find my function f of x. It's a functional equation. Already we did this type of question earlier also. In this January and April 2025 shift also one question was there in terms of log f of n. Nice question was there. There we put x equal to 0, y equal to 0. We got f dash of 0. Then we put y equal to 0 only. We do such kind of technical simplifications. Okay. Do some manipulation so that our ultimate aim is to find f of x. So what here I will do is put y is equal to 0. Put y is equal to 0. What will get? If you put y is equal to 0, you get f of 2x equal to k into sin x. Put y is equal to 0 here. Put y is equal to 0. If you put y is equal to 0, I'll get f of 2x. F of 2x is equal to, putting y equal to 0, k into sin x. K into sin x. So if you replace x by 2, replace x by x by 2 because I want to find f of x. Wherever there is x, you replace it by x by 2. What do you get? 2x will become x. 2 into x by 2 will be x. F of x is equal to k into sin x by 2. F of x is k into sin x by 2. I can use this condition given. F dash of 0 is given half. F dash of 0 is given. So differentiate this. Differentiate. F dash of x is equal to how much? K into derivative of sin x by 2 is cos x by 2 into derivative of x by 2 is 1 by 2. Correct? By using chain rule. Now you can use f dash of 0. F dash of 0 is equal to how much? K into cos 0 by 2, 0 into half. F dash of 0 is given to be equal to half, no? F dash of 0 is given to be equal to half. K into cos 0 is 1 into half. So k into half, k by 2 equal to 1 by 2, which gives k equal to 1. I got k is equal to 1. Using the condition f dash of 0 equal to half, I got k equal to 1. Replace x by 2 so that I get f of x. Then differentiate f dash of x, I get f dash of 0 equal to half. Using that condition, I got the value of k. So I can write my function f of x. My function f of x becomes what from this? K is equal to 1, no? Therefore, my function f of x becomes k is equal to 1. 1 into sin x by 2. So f of x is sin x by 2. Now we can double differentiate this and get the answer. F of x is sin x by 2. Want to find f double dash of 5 pi by 3 implies f dash of x. Derivative of sin is cos. Cos x by 2. Derivative of x by 2 is 1 by 2. 1 by 2 into cos x by 2. Double differentiate. F double dash of x. Constant keep as it is. Constant into variable. Constant write as it is. Derivative of cos x by 2 minus sin x by 2 into derivative of x by 2 is 1 by 2 into minus sin x by 2 into derivative of x by 2 is 1 by 2. So what we get is minus 1 by 4 into sin x by 2. Correct? Second derivative I am getting like this. Minus 1 by 4 sin x by 2. Want to find the second derivative at 5 pi by 3. So put x equal to 5 pi by 3. And also I need to multiply with 24. So f double dash of 5 pi by 3 is f double dash of 5 pi by 3 is going to be equal to minus 1 by 4. When you put x equal to 5 pi by 3, 5 pi by 3 by 2 is 5 pi by 6. 5 pi by 6 is 150 degree. Sin 150 same as sin 30 degree, which is half. Into half. I'll get minus 1 by 8 here. minus 1 by 8. And I need to multiply by 24 here, correct? Therefore, 24 into, therefore, 24 into f double dash of 5 pi by, not 6, 5 pi by 3 it is. 5 pi by 3. This will become 5 pi by 6. We are putting x equal to 5 pi by 3. Angle becomes x by 2, so 5 pi by 6. Sin 5 pi by 6 is half. So 24 into f double dash of 5 pi by 3. Multiply by 24. 24 into minus 1 by 8. That will be how much? That is equal to 24 into minus 1 by 8, which is equal to minus 3, which is option C. A very nice question asked on functional equation. And I'm not doing differentiation chapter for this 2025. I included 1 or 2 questions. I think this belongs to differentiation, we can tell, not differentiability. So I've covered the differentiation questions. 1 or 2 questions were asked in 2025. Very less number of questions in differentiability only. Okay, point to be noted. Differentiability itself, I covered the question, okay, of even differentiation also. Only this question belongs to differentiation chapter because I'm finding first derivative and second derivative. I'm not going to discuss differentiation separately of 2025 paper. Okay, so I'm getting the answer as minus 3. 24 into f double dash of 5 pi by 3. Just multiply and open the bracket, collect the common terms and use compound angle formula. Sin A cos B minus cos A sin B, sin of A minus B. Here sin A cos B plus cos A sin B, sin of A plus B. Just like separating the variables or separating the terms, you divide this to bring denominator. F of 2x plus 2y divided by sin of x plus y equal to f of 2x minus 2y divided by sin of x minus y equal to k. And you equate this to this. So I get f of 2x plus 2y equal to k into sin of x plus y. Put y equal to 0, I get f of 2x. And from f of 2x, you can find f of x by replacing x by 2. K into sin x by 2. You can find the constant k by using the condition given. F dash of 0 equal to half. Differentiate and find the constant k. Constant k becomes equal to 1. Half cancels. K equal to 1. K equal to 1 is substitute. F of x is sin x by 2. Differentiate derivative of sin x by 2. Cos x by 2 into derivative of x by 2, 1 by 2. Constant keep as it is. Derivative of cos is minus sin. Minus sin x by 2, derivative of x by 2, 1 by 2. Minus 1 by 4 sin x by 2. And substitute x equal to 5 pi by 3, get the answer. Move on to the next one. I think this is the last question of 2025, both including January shift and April shift 2025 paper of the chapter continuity and differentiability along with differentiation. Okay. So here determinant is given here. Want to find d square y by dx square plus y is equal to how much? Y of x given like this. So differentiate it. You can expand this determinant first. Y of x. Expanding this determinant. Expand it along the first row. Sin x into leaving the first column first row. Leaving first column first row. What do you get? 28 into 1. 28 minus 27. That is 1. Minus cos x into leaving second column first row. 27 into 1 minus 1 into 27. 27 minus 27, 0. Plus sin x plus cos x plus 1. Sin x plus cos x plus 1 into leaving third column first row. 27 into 1. 27 minus 28, which is minus 1. This part is 0. So what remains is y of x equal to sin x. This is 0 here. Sin x into minus 1 minus sin x. Cos x into minus 1, that is minus cos x. Plus 1 into minus 1 is minus 1. Sin x will cancel there, correct? So y of x becomes equal to, y of x is equal to minus cos x minus 1. Differentiate dy by dx. Dy by dx. Derivative of minus cos x is plus sin x. Correct? Derivative of cos is minus sin. Minus of minus plus sin. Derivative of 1 is 0. Again differentiate. D square y by dx square. Double differentiate. Derivative of sin x is cos x. Correct? Derivative of minus cos is plus sin. Derivative of cos is minus sin. Minus of minus plus sin. Derivative of sin x is cos x. Second derivative we got. Now find out d square y by dx square plus y. Thus d square y by dx square. Very simple question of all. I think this is d square y by dx square plus y. Whoever got this paper to attend, very lucky. Lucky to get 4 marks so easily. D square y by dx square is cos x plus y we got minus cos x minus 1, correct? Minus cos x minus 1 plus cos x minus cos x will add up to 0. So we'll get minus 1 as answer. Option C. Very simple question. Just expand the determinant. Expanding along the first row. Sin x into 28 minus 27 1 minus cos x into 27 minus 27 0. Cos x into 0 0 plus sin x plus cos x plus 1 into 27 minus 28 is minus 1. Sin x, here this is 0. Sin x into minus 1 minus sin x minus cos x minus 1. Sin x will cancel. Minus cos x minus 1. Differentiate sin x 0. Sin x minus 0. Derivative of sin x cos x. Add it. D square y by dx square plus y. Cos x plus minus cos x will add up to 0. Minus 1 is the answer. So with this, all the questions of 2025 JEE Main continuity and differentiability. Along with this, also I included the differentiation of 2 questions. Okay. All the questions have been solved completely along with the concepts explained in detail. Everything is a question based on the functional equation. This is very nice question on finding the points of non-differentiability and discontinuity. Okay, and this is again a question related to integration, somewhat functional equation, not exactly. This is a functional equation, typical JEE level question. For very nice question asked on functional equation. This is a question on discontinuity and non-differentiability. This is also a question based on discontinuity and non-differentiability. This was a question wrong given by NTA. I corrected the question and explained so many things here about cos of mod x, all those things about the modulus function, and also drawn the graph of mod of x square minus 3x plus 2 here. Okay, please go through. Synopsis part has to be very strong. I'll be doing the synopsis also, and various theorems are there to be discussed on continuity and differentiation. This is a question on functional equation. No differentiation part is used here, but still I've included this question under this chapter. Okay, and this is a question on continuity, finding the unknowns, and this is on discontinuity of the greatest integer function. And this is a one nice question we had using series expansion, evaluating limit, and also limit x tends to 0, 1 minus cos x by x square equal to half, and one more, limit x tends to 0, tan x minus sin x by x cube equal to half. Tan x minus sin x by x cube is half. Half plus half 1, 1 into 2 is 2. 2 was the answer. This was also a nice question asked. So these are 13 questions we had from this topic. Okay, many more videos will be uploaded in the coming days focusing on JEE mains as well as NCERT first PU as well as second PU, even the KCT PYQs. Synopsis for KCT will be done chapter wise, and also synopsis for JEE exams will be done chapter wise. Okay, with this I conclude. Thank you.